Hi everyone, this is Selvi. Today's topic is what is effort variance or estimation variance. First, let's try to understand what are the parameters that are required to calculate this particular variance. There are two parameters which are required. The first parameter is planned effort in hours, that is also called as estimated hours. Next one is what is the hour or the hours spent actually. Actual hours spent. So there are two parameters which are required. The first one is the planned or estimated hours, and the second one is what is the actual hours that we have spent. Now, how to get these two values? First of all, in Agile, when we are actually implementing an user story, where actually hours get into picture? We use hours in task level estimation. Why actually we can plan for task in hours? How is that feasible? Because anyway we are estimating user stories in story points. What is the need of this? Now this we have already covered in one of our episode, but I'm going to give it in a very simple way here. Why story points for stories and why hours per task? When we estimate the stories, we estimate with lot of factors. We estimate with factors like complexity, business value, amount of work that is required, what are the dependencies involved, what is the risk involved. With all these factors, we come up with the story points. So when considering these factors, there is a very less chance to give absolute values in time, which is hours or days. So we always go with story points, that is called as the relative estimation model. So story points are estimated in so user stories are estimated in story points. Now coming to tasks are estimated in hours. How come it is possible to estimate in absolute value? The reason is when task breakdown will happen during sprint planning. As part of sprint planning, team will be pulling the user stories that are aligned with the sprint goal, and based on the priority, based on the achievement with DOR, with all these criteria, whatever the entry criteria for the sprint and whatever the things that is feasible to be pulled into the sprint backlog, team will be pulling up with the help of the product owner, and it is also assigned with the sprint goal. Now at the same time, team, what they will be doing, the next step is task breakdown. What is the advantage of task breakdown? Initially, we know that what is the user story. User story is a high level work item that is available for the team. Now, to day basis, how are we going to manage our work? That is with the help of task. So what they will be doing, they will be breaking down the user stories with the help of task, which is called as the task breakdown. And when they are doing this task breakdown, they will be entering a value called estimated or planned effort required for this task. Usually what is the general suggestion or recommendation? Not to plan a task more than a day. Every task should fit in a particular working day. Morning, if I'm starting, I should plan it in a way that I am able to complete the task at the end of the day. So that level of detailing the task should have and the breakdown should have. Now we have estimated hours required for a task. Next thing is, now this is happening during the sprint planning. Now estimated or planned effort required is available in hours in every task. At the end of the sprint, what will happen? We will be having what is the effort that has been actually spent for the task every day. At the end of the day, when actually if I'm a team member, when I'm completing a particular task, what is my job? My job is go to that particular task and change the status of the task. In addition to that, what I need to update? I need to update what is the effort that actually I have spent. See, it is not really a case that always the actual hours spent should match with the estimated hours. It can sometimes match, it can go sometimes more than what I have planned, sometimes before even the hours, whatever I have planned, I may be able to complete within the hours, whatever I have planned also. So there is no such reason that this should fit exactly like 10 hours I have planned, so I will be also actually spending 10 hours. It may go to 12 hours also, it may complete within 10 hours, like for example 8 hours also. So whatever we have spent, we should update that. So this will be happening on basis of every day. But here the important thing to remember is we are not going to touch that planned or estimated hours. That is on the very first day, that is on the sprint planning, during the task breakdown we are entering. After that we are not going to change that at all. Only what is going to be changed, the things that are going to be changed is only the, not things, only the thing that is going to be changed is this actual hours spent, which may or may not be equal to the planned hours. It can go more than that or it can be less than that. Okay. Now, at the end of the sprint, what we are going to do, we are going to sum up all these values. Why summing up? Because we are not going to uh, actually find anything related to individual, because Agile, it is all about team. So as a team, how many hours we have estimated for this sprint? At the same time, how many hours we have actually spent in this sprint? We have these two values. What are the two parameters? In the sprint period, how many hours that as a team we have estimated or planned. What is the next parameter? The next parameter is how many hours we have actually spent at the end of the sprint in hours. Now we have these two values. These two values are sufficient to calculate our variance indicators. First thing is to find the indicator. What is indicator? Indicator means it will show whether we are at the right phase or not at the right phase, whether it is red, green, whether good, bad, those kind of indications it is going to tell. So now let's first try to understand how to identify the indicator from this. Now it's very simple. Always use these two parameters, compare these two values. How to compare the values? Compare your actual spent hours with your estimated hours. If it is less, what is less? If the actual hours spent is less, then it is green. I will explain why it is green also. Okay. And the next one is if the actual hours spent is more than estimated or planned, then it is red. What is actually here red and green? Now let's first try to understand the green indicator. Estimation value, for example, estimation effort that we have planned in hours is, let's for simplification I'm telling 50 hours for the team. Okay. And whatever the hours that we have actually spent is 40 hours. So it is very simple now. 40 is actually less than 50, which means the actual hours spent is less than the planned hours or the estimated hours. This means team is actually able to complete the work than whatever they have estimated. Team is able to complete the work well in advance before the estimated value. So if they are able to complete well in advance or before the estimated value, then the indicator is going to be green. Second thing, what is red indicator here? Red indicator is if the team spends more time, the actual spend time is more than the estimated or planned time, then it is red. That means, for example, 10 is the estimation, 50 is the estimated hours, but team had spent around 70 hours. That means team has spent more hours than the planned hours or estimated hours. That means it is a red indicator. Now the question is, Selvi, this is fine, like you are saying red indicator, green indicator, but why I am calculating all these things? What is the advantage of this? What is the calculation going to give me? Because every report, every metric, every time when we are trying to establish a metric or trying to report out something, we need to understand what is the advantage and what is the learning that we are getting from that. So here, what is the learning? Here, what are the things that we are going to do? This is only indicator part I have explained. The second one is we need to understand about variance. So indicator, just comparison, comparing the actual spent value with the estimated or planned value. That's it. If it is less, then green. If it is more, then it is red. Simple. Now the next part is the variance. Variance is always represented in percentage. So how to calculate this? It's very simple. Estimated value minus actual spent value divided by estimated value into 100. Always when I am using estimated value, that is also called as planned value. So I am telling the formula once again. Planned value minus actual value divided by planned value into 100 is the variance percentage. Sometimes what will happen? You can think maybe Selvi numerator may become negative. Please exchange that. It can be like actual value minus planned value also, because depends on green or red. The negation should also be planned. We cannot have minus values, right? Or even if it is minus value, you know what it represents. What actually it represents. For example, if it is 50 minus 40, then it is very simple. 50 is your estimated or planned value, 40 is your spent value, actual spent value. Here it is less, which is green. So whenever the value is positive, that means the variance is showing the green indicator. Whereas for example 50 minus 60, where spent value is more, that means it is going to come as minus 10, right? Which is a negative indicator. That means it is a red indicator. So accordingly you need to put the variance value, whether it is up or down, whether it is green or red, whether it is plus or minus. Now this is done. So this is very simple. Again I'm explaining. First one is you need to understand the green and red indicator, and the second one is you need to understand how to calculate the percentage, that is the variance value. First one is always have estimated or planned value, compare that with the actual spent value. If actual spent value is less, then it is green indicator. If actual spent value, when we are comparing with the estimated or planned value, if it is more, then it is red indicator. Now how to calculate the percentage, that is the variance, that is called as effort or estimation variance. How to calculate it? The formula is very simple. Planned value minus actual value divided by planned value into 100. Again I'm saying numerator plus or minus depends on green or red indication. Up or down, all these things are clear now. Now let's come to the topic of why we are calculating this. That is the main reason we need to understand, right? First thing I'm telling one point very clearly. Even though this value at the end of every sprint, if we calculate, it's fine, we are calculating at the end of every sprint. But suddenly if it is negative or it is in red, don't immediately take an action. It is okay. Then why are we even calculating? Yes, that is a good question. Now we need to understand this variance. We need to learn it as a pattern. I have used in many of my episodes the word pattern. As a Scrum Master, it is very, very important to learn and understand the pattern. Just in one sprint, the value is different. Okay, yeah, we need to do a kind of like root cause analysis, get into the details, understand it, and get into some kind of conclusion, bring some action items, do that action, come up with the action plan. No, it's okay, because how average velocity that we are calculating, it is not a velocity of a particular sprint. Over a period of sprints, like for example 3 or 4 sprints, we are monitoring what is the velocity, and as an average at the end we are calculating. Why so? Because we all know velocity is something which is a fluctuating value. Every sprint it cannot be a constant one. It actually fluctuates, and if it is as a pattern, if it is keep on reducing, then we need to understand why it is keep on reducing. Similar way, the same is applicable in this particular variance as well. Keep observing for different sprints. Understand and learn that pattern, whether it is increasing or decreasing, whether it is always in red or always in green, whether it is always with positive value or negative value, whether it is up or down. These all things we need to manage and see. Now I am going to talk about what are the actions we need to take when there is a pattern that we are observing. For this, it's very important to learn and understand the pattern. Always draw a graph. How we have velocity trend, similar way, whenever you want to understand anything as a pattern, it is very important first you put it in the graph, so that it will give you a very clear picture whether it is increasing or decreasing, or there is a fluctuation. It is not a actual pattern, it is always going up and down, and I'm not really able to understand any pattern. It is only fluctuating but things are fine. Or if it is keep on reducing, or if it is keep on increasing, we should be able to understand from this graph. But what I need to draw in the graph, Sylvie? Yes, that is the next thing. Let's understand how to draw the graph. To learn the pattern and understand the pattern, then we are going to discuss about how we can come up with the action items after the learning. I always request, as it's a audio, I request you all to get a piece of paper, so that whenever I'm saying, please draw it on the paper so that you can understand very clearly what is the graph all about. Have a graph which has x-axis and y-axis. So in the x-axis, it is going to be with all the sprints. When I say sprints, it can be sprint 1, 2, 3, 4, 5, 6, 7, like that. It will be keep going. What is in the y-axis? Y-axis is going to show us the hours. So you can put usually what is the hour that it starts with. For example, in your team, generally the hours may be starting with, for example, the overall, because uh, it should manage for both parameters, planned and actual, right? So for example, your planned hours always in your sprint is somewhere around 100 or 200 or 300. Accordingly, you start the scale, like usually start from 100, 200, 100, 100 as the y-axis. Now you have put in the x-axis sprint numbers, and y-axis you have put the hours value. So in sprint numbers, when I say sprint 1, sprint 2, sprint 3, sprint 4, sprint 5, like that. In the hours, 100, 200, 300, 400, 500, 600, like that. So in the first sprint, what is the planned value? Planned value for effort. How much we have planned, or what is the estimation we have done, that you put it as a single bar graph or single line, whatever it is feasible. Next to that, in the sprint 1 itself, sprint 1 has 2 bar graphs. Let's imagine like that, okay, for easy understanding. Sorry, I am actually making it to making maybe little complicated, but do not think like that. We can make it as simple as that. You have a graph where you have x-axis sprint numbers, and y-axis it has the number of hours. So in x-axis itself, for sprint 1 you have 2 bar graphs. Okay, first bar graph is going to talk about your planned effort in hours. For example, it is 50. Put a, according to 50, map it with the y-axis. With 50 hours, draw a bar graph. Similarly, what is the actual number of hours spent? For example, it is 40. Then add 40, another bar graph. Accordingly, with the y-axis 40 value, draw a graph. So for sprint 1, you have mapped. What are the two things? Two things are, one is your planned value, and next one is your actually spent value. Now this itself will show what is high and what is low. So this itself gives you a green color indication or red color indication. Now calculate its variance. Okay, how to calculate the variance? Planned value. So according to the green or red, you can make that negation accordingly. Okay, so in this case, 50 minus 40 divided by 50 into 100. So now accordingly, get the percentage of your variance. 50 minus 40, that is 10. 10 divided by 50 into 100. So it is like 20%. All right. 10 divided by 50 into 100. So now 50 minus 40 divided by 50 into 100. I think hopefully you would have written that in the paper. So now next thing. So this is the variance value. So draw the graph, okay, on top of this for 20% as the variance. Just put a dot, that's it. Plus and minus, that's what we are just going to display, plus and minus, that's it, nothing more. Now the next thing is, it is not going to be related to the hours. Just make a note on that. Only the hours we are going to understand from these bar graphs, that is actual spent hours and the planned hours. This variance value, whatever the 20%, it's nowhere related to that. Then where I can put this, LV, I'll tell you on that as well, where we can put that. Just to calculate 20%. Okay, now this bar graph is done and you have calculated the variance percentage. Similarly for sprint 2, sprint 3, sprint 4, sprint 5. So now what is happening? On top you have written in red color or green color, 20% means it's green in this case, because for 50 minus 40, that is 40 is less than 50. So it is green in this condition. So it is easy. Similarly in the next sprint, 50 minus 60. 60 is higher. It may be in red, right? Now you have put green, red. So the first graph with indication is ready. And you have also marked the variance. Now in the second graph, put the percentage. What is the second graph? Variance in percentage graph. Because we need to see the trend, right? Earlier we have only seen the indication and calculated the variance in percentage. Now here we are going to put in x-axis, second graph, also same x-axis, print 1, 2, 3, 4, 5. Y-axis, it's all about 1, 2, 3, 4, 5, 6, 7, 8. What is this? Variance in percentage. X-axis is going to be the same, that is print number. Y-axis is going to display the variance in percentage. Now draw the value. If it is minus or plus, now the catch, y-axis is going to have the minus values also. Why minus values, Selvi? Because you need to understand whether there is a fluctuation or not. Sprint 1, green, so the x-axis will be having the positive side of the y-axis. From the x-axis, that is for sprint 1, the y-axis value is in the positive side. But whereas for sprint 2, which is negative, that is red, then the y-axis will have negative. So I think hopefully you have understood how to draw the second graph. The second graph is going to have a y-axis value which is both in plus and minus. Your x-axis is going to be in the middle, which is going to display the sprint. Now if it is variance percentage y-axis, whatever in the top you are putting the plus, just mimic that and put it as negative values in the down. So now draw it, just whatever the variance you have calculated. Just try to understand whether it is always on the positive side or always on the negative side. That pattern we are going to understand. Now in this graph, in this second graph, you will understand whether there is a fluctuation or there is a pattern that you are able to see. I am going to quickly summarize about how to draw the graphs again. I am taking good amount of time, but I want you all to be very clear about this concept. So please take a piece of paper. The first graph, it's very simple. In x-axis, it is going to be the sprints. Y-axis, it is going to be the hours. So the first thing in x-axis is put all the sprint numbers, and in every sprint you are going to draw two bar graphs. What are those two bar graphs? What is the planned or estimated hours, and the second one is what is the actual hours spent. Draw the two bar graphs. Because you have in y-axis the hours, so it's very easy to draw it. And with this you will be able to understand whether it is green or red, because if actual value is less, than the estimated or planned value, then it is green. If actual value is high than the estimated or planned value, then it is red. Accordingly, make a note. And as well, calculate the variance. Planned value minus actual value divided by planned value into 100, that is your variance percentage. Calculate that also and keep it. Now come to the second graph. Second graph, draw x-axis, same x-axis, print numbers. Y-axis is going to have positive and negative. In x-axis, you will have top as well down when you compare to the x-axis. X-axis will be coming in the middle because you have the positive y-axis also, negative y-axis also. Because your variance also, if it is red, that means it is negative. It will come down. So what is the y-axis? Y-axis is going to display the variance percentage, what we have calculated. Now draw this graph and observe whether there is a fluctuation or there is a pattern. Now, as I mentioned, if only one sprint there is something like green or red, don't take any action. When to take action? When you can take action is when you are seeing and observing and learning a pattern. Now, what are the actions, Selvi? You have told actions, but what is the action? Yes, there are two conditions, right? Very simple condition. One is green or red. Let's talk about green and red. I'm not going to talk about variance percentage because this indicator itself will help you to take the actions, because as a pattern you can see whether it is always green or always red, right? So let's come to green. What is green? Green means the actual hours spent is less when compared to the estimated or planned hours. When this will happen? Every time if this is happening means we always overestimate. Chances are there. I'm going to give only the chances. We need to understand from the team through the retrospective meeting actually what is the root cause. But we are trying to understand what are the possible cases. First possible cases, we are always overestimating. Or the second thing is we add tasks that are actually a duplicate. For example, we add review. We add then incorporating review comments. We then add initiating review. Every time if you add 1 hour, but everything may be clubbed as maybe 1 hour because someone else is going to review your code. You just need to initiate. You just create a pull request, then automatically it is going to initiate a review as well. So there are chances you have lot of duplicates in your task breakdown. And the first point, as I mentioned, there are chances that you have overestimated. Third one is there are chances we always undercommit to be in safer side. Okay, let's not get into any kind of spillover. Let's not get into trouble of not completing the task. Let's undercommit. So there are situations that team has overestimated, or we have undercommitted, or we duplicate tasks, or we actually create tasks that can be covered as part of something else, which is additionally adding some hours. So these are the situations which may create always a green indication, because every time we are able to complete, there is no such situation that whatever we have planned, we have not even met that. We are always in the safe zone. That means every time we overestimate, or we undercommit, or we create task in such a way that they are already duplicated, so that already it is taken care. So the next task, there is no value at all. So there is a chance for that as well. So these are the situations that can bring always this green indication, which we need to analyze and understand. And we should also understand about how well our capacity utilization. I'll talk about the topic separately, but I'm giving the hint here about capacity utilization. But we are going to have a separate episode for how to calculate capacity utilization and what is the benefit of that. But we should also give a highlight about that. We should also talk about, whenever we are talking about this particular topic to the team in the retrospective, we should also bring capacity utilization as well. All right, so this is about green. Coming to the red indication, always it is red. Every time it is in a red indication. What are the possible cases? Maybe scope is keep changing. There are frequent changes coming in which are not actually discussed in the stand-up meeting or in any other common meetings, whereas it is always directly going to the team, and the particular team member is extending the hours just to incorporate those scope changes. Chances are there. Next one is we always underestimate. Even though the work needs so many hours, we think that no, I think uh, it is actually it can be taken up in these many hours, but it may not be. And the task breakdown is not to that granular level, because when we deep dive into the level of details, what will happen, we try to go as much as closer to the actual values. But when we are at a very high level, just for the sake of adding the task and just for making the task breakdown, if we are adding, there are chances we always estimate at a very high level, but when actual implementation happens, we need more hours than what we have planned. That is why this indication also may be right. The next one is we always overcommit. This is even a problem we talked about in spillovers as well, but there are also situations that we always overcommit on the things. No, this cannot be even taken care, but we have taken and we have not completed here. We spent so many hours here and still it is not even completed. Then the next story is also taken more hours, which where actually the estimation is also not problem. Estimation is also not correct. That is also a problem. So whenever there is a red indication, what are the chances scope changes may be happening? That is also one option. Second thing is we always underestimate and overcommit, and our task breakdown is not that great. We are not getting into details. These all situations also make the indication red for effort or estimation variance. Now, what is the next step? We have identified. Now, project this information to the team and now do the root cause analysis, because you have learned that as a pattern and this is what is happening, and you are able to understand that this is not happening in one single sprint. It is happening for multiple sprints in the last 3 to 4 sprints or 5 sprints, whatever it may be. We are able to see that this is happening as a pattern. So now it is a warning or an alarm that we got with this effort or estimation variance. This we need to discuss and give all these options. So what are the actions that we can take? Major thing is we need to observe whether any scope changes are coming in. We need to observe how are we really committing. We feel that, oh, these all are priority, let's commit on all these things. These all things are aligned to sprint goal, let's plan all these things in the sprint execution. No, then we are not actually committing according to our bandwidth. We are over committing on the things. We need to understand that. And is there a problem with the estimation? Is all team members, whether all team members are aligned to what is estimation, how are we doing it, whether any kind of a quick workshop or session is required to understand better the estimation, we may need to plan that. And task breakdown, how are we doing it? Is there something like we are doing, thinking about what all the tasks that are coming in, or just like that, okay, let's add all these things and later part in implementation, let's plan it? Whether do we have that kind of understanding about task breakdown? That also we can plan a session or we can plan some kind of workshop to understand it better. So these all are the action plans that we need to derive from our retrospective meeting once we learn that we are able to see a pattern. In the next episode, I will also talk about what are the best practices in task breakdown. That is very important. I'll talk about that as well. But here, this is also one point we need to think about. So I think this episode, we talked about how to calculate the effort or estimation variance and why it is used in Agile when we have already user stories when already we have user stories which are estimated in story points, where actually we use this effort level things in hours, that also we discussed. Then green and red indication, then calculation of variance percentage, then how to learn and understand from the graphs. We took some time in drawing those graphs, and from those graphs how to come up with some kind of action items, and from that what are the possible cases to take some actions. These are all things we have discussed. I think this episode would have helped many of you in understanding about effort or estimation variance. Thank you so much for listening. Happy learning and stay tuned.